When planning lessons, educators identify learning goals and connected success criteria related to curriculum expectations and mathematical big ideas. For the lesson found in this resource, the teacher has identified 3 learning goals. These goals apply not only to this single lesson, but also to other lessons that have preceded and will follow. One learning goal addresses curriculum concepts and content related to surface area. A second goal speaks to the process expectation, communication. The third goal focuses on effective partnerships and interactive skills among students. This goal has received ongoing emphasis not only in mathematics, but across all areas of the curriculum. In the following, the teacher describes her thinking relative to the first goal, connected to surface area.
And the learning goal that I'm looking for is seeing that relationship between the volume and the surface area. As the layers increase, or as the shape becomes more like a cube, that the amount of packaging is going to decrease. The other thing that hopefully we'll be looking at too is the fact that the volume isn't changing, and that is really connected to the surface area. The volume can stay the same, but the surface area can change.
Ann Davies describes criteria as the finer and important attributes that identify quality work. Growing Success notes that success criteria should provide more specific descriptions of learning goals. Success criteria are effective when they emerge from problem-solving lessons and discussions, rather than being simply listed or shared with students. Problems are intentionally selected to assist students to uncover the finer attributes or criteria relative to the learning goals.
I think the reason why students are better able to retain or hold on to the concepts is that they have a context to help them with that. So the fact that they can refer to the chocolate bar problem, or the problem that we did with the food drive, or the problem that we did with the skating rink, they can make that connection between the context of the problem and the work that they did on that day.
Success criteria are meaningful when elicited from student work, conversations, and representations.
The first group I'm thinking about having share is this group that found that relationship between the layers and the packaging. And I'm going to ask them specifically to share about that. So I'm going to ask, what did you discover while you were working with your partner about the layers and the packaging? The other group that I'm going to have share is this group here, and they did a really nice job of thinking about the different possibilities that there could be. So rather than just getting fixed on building one and that's it, they looked at multiple different solutions, and it was really nicely, clearly laid out, I think, as a visual for the other students in their class to see.
Depending on where students are, some criteria the teacher has identified in the planning stage may emerge, and some may not. As well, additional criteria not considered by the teacher may also emerge.
You might try a problem one day and they don't come to the learning target that you had set. So it's really important that you're flexible and that you understand that some things might take a little bit longer. You might need to go backwards at some points before you can move forward.
Communication, one of the 7 mathematical processes, is the focus of a second learning goal identified by the teacher for the lesson in this resource. Through the course of the lesson, success criteria relative to this goal are observed and highlighted with students.
So today, when you're working with your math partner, I want you to be focusing on one of our learning goals, which is our communication. So to communicate your math thinking orally, so using your words, and in writing, using our math vocabulary. Okay? Taylor?
Are we going to be doing a ticket out the door?
Yes, we will be doing a ticket out the door today, so keep that in mind. No, but I see a pencil. Just talking about, again, the systematic way that they thought about their work, that they have this nice chart where they've included the layers, the width, and the length, might be another solution to look at. I'm thinking something else. I'm wondering, if we were to share this work with your classmates, there's work all over the place. I'm wondering if there's a way we could think about organizing our ideas so that they're a little bit more clear.
Well, we could do all this, but take the ideas that we want to share and put it on the back and organize.
Sure, and there's more chart paper on top of the fridge if you need more chart paper.
Okay.
So think about too, when you're putting those ideas together, what's a really good way mathematicians organize ideas?
Well, they're gonna probably go put them in order.
Okay. Okay, so I want you guys to talk about that. Okay. How can we get these ideas organized? And then that thinking that you told me at the end, how you've changed your mind, right? Let's make sure we get that down.
In an ongoing third learning goal identified by the teacher, students are called on to review the characteristics of effective partnerships.
What makes a good partnership? What are we going to be working on today? Ed?
Cooperating with your partner.
Okay.
Making sure you're staying on task so you're not fooling around with your partner or other partners.
Both people contribute, so they both do the work.
Yeah, and not so one person doesn't do all the work, you have to share the work equally.
Yeah, it's like a partnership instead of it being individual. Yeah, it doesn't make sense if you write it and the other person just says it. Yeah,
As evidenced in the following student-to-student dialogue, interactive strategies and active listening have been a major focus throughout the year and across the curriculum.
Got our 4 options, but it's kind of hard because there's not one. And then we have because right here, because they both equal up to the same amount of apples. But right here is also equals up to 24 apples, and that's our original thought.
But it's kind of hard to decide which one is easier to. Because there's this one, and then there's that one.
So.
I'm kind of more on this side for that one because that one looks less than having it stacked up on top like that one.
Yeah, because if you put it's like this, then it would just feel more.
I think more along the lines of that.
So I think that one. So why do you think that this box right here?
Well, if you look at it, it kind of does look like it equals up to the least amount of cardboard.
Because if you just imagine what these boxes would look like in a truck delivering apples to a place, I think that would probably be a little bit more better. Because if it's this, then it would take up more room in the truck, which means less apples for that place.
And if you go this way,
then it would provide more room so you could bring in more apples.
It's this is the back of the truck right here. If you had that one, then you have it there, and then it's
But
The consolidation, highlights, and summary portion of the 3-part lesson provides a time and structure for students to formally give voice to their collective understandings and mathematical thinking. Together, the teacher and students co-construct the criteria that have surfaced during the learning experience. These are recorded using student-friendly language.
So the volumes stayed the same.
Surface area changed, but the shape and surface area changed.
Educators identify learning goals and success criteria when planning lessons and cycles of learning. Success criteria are the finer attributes of a learning goal. Success criteria support learning when they emerge from meaningful problem-solving experiences and discussions. They are co-constructed with students and framed in student-friendly language. Student thinking is honored when learning goals and success criteria are developed in a manner that does not limit students' mathematical decision-making, inquiry, and reasoning.